All right, here we go. So it's been a while since we've done any of these guided notes or any of the videos online. So just remember, whatever I write down, you want to write down as well. But this is lesson 4.1. So we're moving into module 4, and this is on sequences. So let's start with what is a sequence. So a sequence is, or sequences are ordered lists of numbers. Each number in a sequence is called a term. So each number in a sequence is called a term. And term is in the box because it is another key word, a key vocabulary term. So here's some examples of sequences. 3, 5, and 7. It's a list of numbers. Now 3 would be your first term, 5 would be your second term, 7 would be your third term, and that ... just means that this pattern of numbers can be extended. Now we can take that list and put it on a table. So for example, your position number, so which term are we looking at? Term 1, term 2, or term 3 would be your input. Also would be your domain. So position number, or the term number, and then the actual term itself, the number that's in the list first, would be the term of the sequence, or f of n, which is your output or range. So my first term is 3, my second term is 5, and my third term is 7. So that's one example. Another example of a sequence, 21 is your first term, 16 is your second term, 11 is your third term, and 6 is your fourth term. ... We can extend this pattern if we wanted to. So my position number, 1, 2, 3, 4. What's my first term? It's 21. Second term, 16. Third term, 11. And fourth term, 6. We could get our domain and range from here. So for example, my domain is my values for n, or my term position, 1, 2, 3, 4. And my range would be the terms themselves. So 21, 16, 11, and 6. So that's my domain and range for this example. And then one more example. If we have 1, 2, 4, and 8, term 1 is 1, term 2 is 2, term 3 is 4, term 4 is 8. And then my domain is just 1, 2, 3, 4. And my range is the actual terms themselves, 1, 2, 4, and 8. So you might have noticed, okay, some of these sequences have patterns like this first one would be plus 2, plus 2, plus 2. The second one would be minus 5, minus 5, minus 5. The third one wouldn't be adding. It would actually be 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8. So sequences can be extended, like we said, if they have those little ... dots, by following their pattern. So your job in this lesson is going to be to figure out what pattern is happening. So for example, 3, 8, 13, you notice 3 plus 5 is 8, 8 plus 5 is 13, so 13 plus 5 would extend this pattern to 18, and 18 plus 5 would extend this pattern to 23. It's not always adding, sometimes it's subtracting. Like 20 minus 3 is 17, 17 minus 3 is 14, 14 minus 3 is 11, 11 minus 3 is 8. Whoops, sorry, minus 3, not minus 8. Okay, sometimes it's neither adding nor is it subtracting, but it's multiplying. So like 3 times 2 is 6, 6 times 2 is 12, 12 times 2 is 24, 24 times 2 is 48. Or division, like we have here, 40 divided by 2 is 20, 20 divided by 2 is 10, 10 divided by 2 is 5, and 5 divided by 2 is 2.5. So we can extend those by following whatever pattern we see in those lists. All right, let's go to the back page. So what we're going to focus on for 4.1, or actually all of Module 4, are a specific type of sequences called arithmetic, and it looks like it is the word arithmetic. It's really arithmetic. Arithmetic sequences. Now these are patterns of numbers that add or subtract a value to get to the next term. So we're only going to deal with addition and subtraction in arithmetic sequences by adding or subtracting. We won't be doing multiplication or division with arithmetic sequences. So we've got arithmetic examples and non-arithmetic examples. In our arithmetic examples, our first sequence would be 3, 5, 7, 9. So we are adding 2 to each term to go from one to the next. In our second arithmetic example, we have 21, 16, 11, and 6. So you can see we're subtracting 5. Now how do I know it's arithmetic? The difference, or the space between each number in the list, between consecutive, that means one right after the other. So the difference between consecutive terms is always, this is an always statement, the same. So you can see the difference between 3 and 5 is 2. The difference between 5 and 7 is 2. 7 and 9 is 2. And same thing here. All of their differences are minus 5. Now here's a not arithmetic sequence. If we go 1, then 2, then 4, then 8. First we're adding 1, and then we're adding 2, and then we're adding 4. So this difference does not stay the same like it does over here. In the second one, we go 100, 50, 25, and then 12.5. You can see we're subtracting 50, and then subtracting 25, and then subtracting 12.5. That difference is not the same like it is here. So it's not arithmetic when our difference between consecutive terms is not the same. Okay, so that's arithmetic. We're always adding the same value from one term to the next, or we're always subtracting the same value from one term to the next. Now that number that gets added or subtracted, we call the common difference, and we have a variable for it. We call that D, and D is the constant difference between consecutive, so that means one right after the other, terms. So if we look at 10, 21, 32, 43, our common difference, or D in this case, would equal, sorry, not 10, 11 plus 11. We're always adding 11 from one term to the next, so our common difference equals 11. In our next example, -2 plus -3 gives you -5, plus -3 gives you -8, plus -3 gives you -11, so our common difference here would be -3. So we've looked at our sequences. Now, we don't just have to use lists to show these sequences. Just like in our previous modules, we have formulas, tables, and graphs represent sequences. Okay, so if we look down below, we've got a table on our left. So on our table, N represents, as we said before, the term number. So we've got 1, 2, and 3. And F of N, now that's your output, that represents what we call the nth term. So really that just means any number term, the first, the second, the third, the fourth, the fifth. If we're talking about all the numbered terms, we say the nth term. So the first term is 3. We're going to put the first term is 3. The second term is 7. So the second term is 7. And the third term is 11. So the third term is 11. So we could go tables, we could go words, we could put this on a graph. So our output is f of n, or the nth term, and our input is going to be our term number, or n. So when n is 1, f of n is 3. When n is 2, f of n is 7, and when n is 3, f of n is 11. And hopefully you're noticing what kind of graph is this, and you see that it is linear. It is discrete. We are not going to connect those points because there is no term 1.5 or 2.3. It's only term 1, term 2, term 3. So nothing in between. All right, so that's the first 2 pages. Oh, let's take a break.